Hi, this is question 1 from AQA Mechanics 1B, the January 2013 paper. The question is about kinematics in one dimension. If you've not already had a go at this question, you might want to have a go at this first before you watch the video. A car travels on a straight horizontal racetrack. The car decelerates uniformly, and I'm just going to grab my highlighter pen so I can say that it decelerates from a speed of 20 meters per second to a speed of 12 meters per second as it travels a distance of 640 meters. The car then accelerates uniformly, traveling a further 1,820 meters in 70 seconds. Okay, so I've highlighted all the key information there. The first part of the question requires us to find the time that it takes the car to travel the first 640 meters. So we can see from the question that it's decelerated from 20 meters per second to 12 meters per second, and it's traveled a distance of 640 meters. So for part A, what I'm going to do is I'm going to write down the word suvat, and I'm going to work out, well, I'm going to read off all the values that I know. So I know that the displacement is 640 meters, so I can fill that in, and I also know that the initial velocity here is 20 meters per second, and I'm also told the final velocity is 12 meters per second, and the acceleration and the time is yet to be found out. So we need to find the time out first of all, so I can go ahead and write down the equation I'm going to use for this, which is I'll just change colour, and it's S is equal to a half of U plus V times T. Okay, so I can stick in all the information I know, so I know that that's going to be 640 is equal to a half times 20 plus 12t, which means that 640 is going to be equal to 16t, which tells us that t is going to be equal to 40 seconds, and I can now fill in this bit here, which is going to be 40 seconds. I'm just going to underline this here to show that that's my answer for part A. Now for the second part of A, I need to find the deceleration of the car during the first 640 meters. So part 2 over here. Okay, so I know the displacement, the initial and the final velocity, and the time that it's taken, so I need to work out the acceleration part, which is that part there. So I'm going to use the formula B is equal to U plus A T. Okay, so my final velocity is 12, so I've got 12 is equal to my initial velocity is 20. I'm trying to work out what A is, and my time is 40 seconds. Okay, so if I rearrange this, I've got minus 8 is equal to 40A, which means A is going to be equal to minus 0.2 meters per second. However, we have been asked for the deceleration, so my answer for this here is going to be my deceleration is equal to 0.2 meters per second. Right, part B wants us to find the acceleration of the car as it travels the further 1,820 meters. So this is now a new stage in the question. What I'm going to do is I'm just going to, let's just minimize this here. I'm just going to put this over here so it's kind of out of the way. Now I can carry on over here, right. Okay, so we want to know the acceleration of the car. So I'm going to go again and I'm going to write down our suvat again. Okay, so we know that the displacement this time is going to be 1,820 meters. Our initial velocity, well, our initial velocity in this stage is going to be the final velocity of the last stage. That was 12 meters per second. Our final velocity we don't know. That acceleration we don't know. But this time we know that our time is going to be 70 seconds. We're going to put the time there as 70 seconds. Right, okay, so we want to find the acceleration, so I could use my formula S is equal to ut plus a half at squared. So if I stick in the values that I know, I've got 1,820 is equal to 12 times 70 plus a half a times, and that's going to be 70 squared. So just tidying up that, we've got 1,820 is going to be equal to 840 and plus, and that's going to be 4,900, so 2,458. And if we tidy that up a little bit, we should be able to work out the acceleration. Okay, so that's going to be 980 is equal to 2,450 A, so A is going to be 0.4 meters per second. Okay, so our next part for B asks us to find the speed of the car when it has completed the further 1,820 meters. So this is our answer for part A, and what we want to know is this bit here. Okay, so to work that out, we could use our formula. I'll write it down over here. Okay, so I'm going to use V is equal to U plus AT. So that means that V is going to be equal to 12 plus 0.4 times by 70, and that will work out to be 40 per second. Okay, I'll just underline my answer there. and I'm again going to condense that up and move that over there. Okay, so part C wants us to find the average speed of the car as it travels 2,460 meters. So to work out the average speed, we need to do the total distance divided by the total time. So our total distance travelled over the period is going to be our 640 meters that were travelled initially at the 1,820 meters, and we need to divide that by the total time. So we had 40 seconds in the first phase and 70 seconds in the second phase, so we've got 40 plus 70. Okay, so that's going to work out to be 2,460 over 110. And if you put that into your calculator, we should get 22.4 meters per second, and I've rounded that to 3 significant figures.